Hey physics students, how's it going? Yes, I'm wearing a Grinch onesie. It's pajama day at the school, so gotta rep my pajamas. So you'll see a couple of videos in the little Grinch onesie here. So let's talk about our last 2 weeks, what they're gonna look like in the sense of our content as well as what you can kind of expect for these last 2 weeks. So for the last 2 weeks, we're gonna go over what's called two-body problems or multi-body problems. It sounds a little more complicated than it actually is. It's actually quite simple. I really like these last 2 weeks in the sense of usually students do really, really well because it's mostly a review of the forces that we've done before in the sense of like we start off pretty easy with just like normal friction, going into angles and then on an inclined plane. So it's kind of a review of the last 3 weeks. The only thing that changes is basically objects are attached to each other. And that's why we say two-body or multi-body. That body just means like there's more objects that are actually attached to each other. So here's a really example. Two pieces of blocks attached by a string. I can't move one without moving the other. So that's what I mean by a two-body problem. A multi-body problem would basically mean that there's more than two. And I think the most that I go into is 3 objects attached to each other. So that's what we mean by multi-body problems, okay? So let's go through a few scenarios of how to figure out finding either acceleration or finding out something else here, okay? So this video is not going to have any calculations. It's just going to be going over the understanding part and maybe how to calculate these. Obviously, my next couple of videos will go into the actual calculations of finding acceleration or finding some kind of friction to cancel out movement. All right, let's go through an example 1 here. So I'm going to try and make sure that you can see the metal side for one of these. We have 2 blocks here attached on a rope. We're going to say that my finger is like a pulley, a frictionless pulley in the sense of there's no friction slowing these things down. We're going to say that this block, the metal block, has a mass of 3. This other block has a mass of 5 kilograms. So if we had these 2 on pulleys, mass of 5, mass of 3, what would be happening to these objects? Well, if you thought like the one with more mass would actually start moving downwards, you'd be correct. Okay, this would start moving down and pulling the other one up because it has more mass. How do we actually find the actual acceleration of this? Well, there's no force applied in the sense of no outside force is actually pushing or pulling on it as of right now. So there's none of that. The only thing that there is going to be force of gravity. There's a force of gravity on this, 5 times 9.8, and then this is 3 times 9.8. So if you imagine that basically they both have a force of gravity, this one being bigger, how do we know what the net force is? It's just going to be like basically taking those 2 and subtracting them, okay? Because those are the only 2 forces. It's very similar to where we went at the very start, in the sense 2 people are pulling on an object in opposite ways. How much is one winning and by how much? That's your net force. Same exact scenario here. We have one object pulling down like kind of to the right, if you want to say, the other one pulling down to the left. This one's winning, and then you find the 2 force of gravities, you subtract them, that's how you get your net force. Now the one thing that always changes, and it stays constant for the whole next 2 weeks, is about our masses. Usually for the other questions for the last 4 weeks, you would have an object, okay, just mainly one, and you would find a net force and divide by that mass. So a lot of people when they first do these questions say, okay, this block is the mass of 5 kilograms, it's the one moving. So once you find the net force, you divide by 5 kilograms because this is the one moving, which I granted does make sense. The thing is, if I move this one, the other one moves as well because they are attached. So for not only this question, but for all two-body or multi-body problems, when you are finding acceleration, we have to find the mass total. What I mean by that is you have to add all the masses. This one's only 2. If I had 3 blocks, you'd have to add all 3 together because, again, one can't move without the other. So when you have to find an acceleration, if you have that net force, just make sure that you add the 2 masses together. So 5 plus 3 is 8. Once you get that net force, divide by 8, and that is going to be how do you find your acceleration, okay? So that's the one big thing that kind of is standard for this whole unit. Once you get a net force, who's winning it by how much, you have to divide by what's called a mass total. Basically all the masses added together. So not too bad there. So there's one scenario. Here's scenario 2, and I'll end kind of my video on scenario 2 here, and then I'll kind of get into some other scenarios, is if we have a block that is over the edge and a block that's here. Now if I let go, it's going to move, and let's talk about why. Again, there's no force applied, right? Now I'm applying a force to keep it there, But when I let go, there's no force applied. No one's pulling or pushing on any of these objects. It is just gravity working on its own. This, again, we're going to say these masses are the same. For this new scenario, mass of 3, they're the same. So this has a force of gravity pushing or pulling down. So that's pretty easy, 3 times 9.8. Now this one has a force of gravity, but the table is canceling that out. Okay, if I were to just lift this, does this move down at all? No, it has no downward force because the table is canceling out with force normal. That's what is holding this up. So when I have these two, what's the only force right now pulling down? It's this block. Now this block does create a force. It creates a force of friction because it's on a table, all right? And so there is going to be an opposite force. It's going to be the force in this direction of friction wanting to slow this down, all right? So again, to find friction, you just go force normal times mu, and obviously I'll give you the mu in all these questions for this one. So force of gravity and force normal are the same in this one. There's no angles, yay, for this one. So force of gravity, force normal are the same. Now, could I have these two objects? If they're the same mass, obviously the one's going to move down. Okay, but if I start adding, oh, where'd my mass go? There it is. If I start adding masses, all right, I could get to a point where this thing would have enough friction. Let's maybe try to turn this over. Where it doesn't move anymore, and that's because I've added more mass here. I've added more force of gravity, which is the same as force normal, and because force normal grows, and so does the force of friction. So now I have more force of friction than this force of gravity pushing down. So there's kind of a scenario number 2 for you, in the sense of like, how would I find acceleration? We're going to see like what force is winning. The 2 force here is this force of gravity pulling down. This is the force of friction. Again, if I let go of this object, force normal goes down, force friction goes down, the object starts moving in. So there's kind of a second scenario for you. We'll do another video basically showing a couple calculations for those two, and then I'll do another understanding video talking about multi-body, maybe with 3. All right, class, thanks so much.